All right, AP Physics C. A little bit poor quality on this mic, but I got an email from a student, and they were absolutely correct about one of the issues here. Let me just talk about a couple of these problems quick. First, on number, so as you go through the solutions, realize I'm taking the area under the velocity versus time graph to get these displacements, okay? I'm being very rough in the way I'm doing this. This is a small graph, all right? Often I'm using the change in velocity as the height of the triangle, right? Like in number 3, I'm using these change in velocities from here to here to find for the heights of the triangle. I actually broke this up into 4 different shapes: a rectangle, rectangle, triangle, triangle. You know, it's it's tricky. When I said on number 5, I said it's pretty similar to number 4. It was actually, I meant to say it's pretty similar to number 3. Number five's um, number five's velocity versus time graph is really not that much different than number three's. I meant to say number 3, so it's pretty close to 581 meters displacement, right? The only difference between 3 and 5 is that for 5, the acceleration goes down at a constant rate. It doesn't instantly change. It doesn't change the shape of velocity versus time graph very much, right? Rather than being linear, which that drawing's terrible, right? It's so small. Um, it curves a little bit, right? It goes down at a constant rate because you have constant negative acceleration. So velocity goes down at a constant rate, and then it velocity levels off. So at the end of this time interval, we'd be going at a constant 42.5 meters per second. So this isn't right. This should be more like 580 meters. All right. So that was a good catch. Now the other question here is the tricky. This one here, right? How do you relate these 3 curves with this varying acceleration? Right. That's tricky. So your acceleration is sloped. So that means it's non-constant. It's a negative slope, right? So that means the acceleration is decreasing. So the velocity versus time graph has to have a slope of positive 5 meters per second squared in the beginning. The velocity versus time graph has to have a slope of 0 because the acceleration is 0 at the end of the 10 seconds. All right, and how does it get there? Well, it's 5 into 0. So the velocity, you use your slopometer, right? The velocity starts off uh, at 0. Velocity is 0, but it's accelerating at a rate of 5 meters per second squared, so it's got to be steep. At the end, the velocity is now 25 meters per second because the area under that acceleration versus time graph is 25 meters per second. But the acceleration has now gotten to 0, so the velocity is going like this. Now, how does that correspond to the position versus time graph? Well, all right, so you got to go a step farther here, kind of backwards. So the velocity, you can't, the shape of the velocity versus time graph you can't get hung up on, right? For generating the position versus time graph. We can't really hand draw how this curve is changing of the position versus time graph based on the shape of the velocity versus time graph. What you want to think about is how the value of the velocity is changing. Velocity starts off at 0 meters per second. So that means the slope of the position versus time graph must start off at 0 meters per second. So it has to start off with a flat slope. Now, the velocity is positive the whole time, and the velocity is positive and increasing at the whole time. So the slope of the position versus time graph has to start off at 0, and it has to end up at 25 meters per second, the slope of the position versus time graph. So it goes from 0 up to 25 meters per second. I guess I should do it this way. Okay, so we're backwards on the screen. So 0 to start off with, 25 meters per second by the time you get to the end. So that's why this has got to curve up. The velocity is going up, so the slope of the position versus time has to go up. It has to get steeper. Now the shape of it isn't going to be a quadratic parabola, right? Since this is curved, since this is linear, this is curved, this is extra curved. So this is linear, this is quadratic. This would be 2, 3, would be cubed, right? But anyway, so that's how that goes, and that's that. So these are kind of hard. Um, it is what it is. It's kind of similar thing here, right? The curve here. How do you differentiate? Well, you don't spend too much time trying to figure that out. You know, the velocity is 80, so in the middle, the slope of this line has to be 80, and by the end, the slope of the line has to be 42.5 meters per second. So the slope's got to decrease towards the end, but it still has to have a slope at the end. I was very rough in some of these displacement calculations. Look, I just made a big triangle here. That was kind of lousy. It's bigger than that, right? You got a little more space there and there, but I just did it very roughly. One thing kids will do for this type of shape is they'll draw a rectangle, like halfway through, roughly, and so that the area here compared to the area above the line they draw is roughly equal, right? So then this area that you're over calculating accounts for this area up here that you're under calculating. So that's something that people will do for that, and that would be more like 10 times 6.5, which would be, well, basically 63 meters. So, you know, it'd probably be maybe even a little higher, more like 8 meters per second times 10, more like 80 meters perhaps. Hard to say. And then here, I didn't do this one. All right. If you have any other questions, please email me. Thanks for the person who emailed me that question. Again, to recap, I was wrong. No, I was wrong on 5's distance. I knew it was, I said number 4, but I don't know what I was thinking. It's not much different than number 3, right? Basically the same shapes. It's about 580. I fixed it on the solution. I'm going to upload that. I just quickly, roughly estimated it to be like 600 even. Whatever. It's close enough for these little tiny drawings. Okay, it's more the mechanics of it. The area under the curve of acceleration versus time tells us change in velocity. The area under velocity versus time tells us position. All right. So I'll update that page in the solution and repost the PDF file. Okay. Thanks a lot. The person who did that, I'm going to give you a bonus point. Okay. Thanks a lot for asking that question.